Okay, so again, the table of trig ratios, which is what you would just get if you're using a calculator, but in case you don't have a calculator handy, that will help you. And then the other one's the PowerPoint. I'm going to put a link in the chat box, and it's just for a web calculator, in case you don't have one handy. And you can do the trig functions on this online calculator. So you can use that. So our objectives for today, initially we're just going to look at a few questions to help you with your unit test that is assigned to you today. Mrs. Williams reviewed for the Unit 4 test last week, so please make sure you watch that recording if you need some help with that test. We're just going to do a few questions at the beginning in case you haven't taken the test yet, and then we're going to go into talking about trig ratios. So you will use trig ratios and inverse trig ratios to find missing angles and sides of a triangle. Okay, so let's just look at a few questions from the unit test. Let me give you the correct polling tools. Okay, so are you ready? Given the following, that the measure of arc ED, which is this arc right here, is equal to the measure of arc DB, and is also equal to the measure of arc BC. So I'm going to put a mark there so we know that these are all equal to each other from the information they're giving us. In circle F, what is the measure of angle EFD? So right here, this is a central angle. What is the measure of this central angle EFD? If we're given all of this information, that these arcs are congruent to each other, and also that this inscribed angle is 35 degrees. So there's two theorems that you have to remember here. You have to remember about the inscribed angle and the intercepted arc. There's a relationship between these two, and then also the central angle and its intercepted arc. So choose your answer, A, B, C, or D. And if anyone wants to get on the microphone, if they know the answer, get on the microphone and explain it, or write on the whiteboard, give us a little explanation on how you get your answer, let me know. Yes, we'd love to hear your voices, so it would be awesome if one of you got on the microphone and let us know how you got your answer. Any takers? Anyone who has their microphone all set up? Madison, awesome. Okay, let me give you microphone privilege, and you can go ahead.
So I got my answer from the fact that in an inscribed angle, so that 35 degrees is, that arc is 2 times the 35, so it'd be 70. And since arc CB is equal to DE, that means that S, since it is a central angle, it equals 70 degrees too.
Awesome, Madison. That was a great explanation. Thank you so much. So Madison explained the intercepted angle and how that is half, the inscribed angle, how that is half of its intercepted arc. So since this angle here is 35 degrees, that means this arc is 70, 2 times 35, right? So if we think of the rule that was given to us, if this angle is x degrees, then this arc is 2x degrees, right? And then also, she talked about the central angle theorem. If we have, let's pretend that looks like it's in the center of our circle. If this is x degrees, then this arc is also x degrees, okay? So the central angle and its arc are congruent, equal to each other, and the inscribed angle and its intercepted arc, the inscribed angle is half of that arc. Okay, so those are the two theorems there that she used to come up with her answer. So the answer here is D, and it looked like 5 of you guys, only 8 of you chose an answer, so there's a lot of you guys who didn't choose an answer, and 5 of you chose D, so nice job those of you guys who chose D for your answer. And if you are confused, let me know if you have any questions. Okay, let's look at another one. Okay, in circle O, which of the following is a tangent? Okay, anybody want to get on the microphone and tell us what a tangent is and what a secant is? or write it on the whiteboard. So give us a little explanation. What is a tangent and what is a secant? And if you don't want to get on the microphone, you can even just write it on the whiteboard. What's the difference between a tangent and a secant? And in the meantime, the rest of you guys choose your answer. Which one is a tangent? Is it SD? Is it OC? Is it RC? Is it OH? I'm giving everyone whiteboard privilege, and I'm giving everyone microphone privilege right now. So if there's anyone who either wants to write it on the whiteboard or get on the microphone to explain us the difference between tangent and secant, go right ahead. Okay, I believe Madison, you wrote that for tangent, and that is correct. So a tangent, it only intersects a circle at exactly one point, and we call that the point of tangency. So someone also chose option B here, saying that SD is our tangent, and that is correct. We can see that SD is intersecting the circle at only one point, and it, right here is the point of tangency. Okay, and I'm seeing some good explanations in the chat box as well. So the tangent intersects the circle at one point. The secant intercepts the circle at 2 points. Okay, so if we were actually, let's say we were to extend that line from there, this would actually be a secant line right here, line CR. That would be a secant because it's intersecting twice, but SD is only intersecting once. So a tangent intersects the circle at 1 point, and a secant intersects the circle at 2 points. All right, good job, guys. Okay, circle A has a radius of 7 centimeters. So radius is 7 centimeters. Arcs RC, CS, and SM are congruent. So let me mark those on the picture. We're looking for arc length. To the nearest hundredth, what is the length of arc RC? So I'm going to make that X. That is what we're looking for. So we need the arc length formula, and if you remember that, it is our central angle over 360 degrees times the circumference of our circle. So 2 times pi times the radius. Okay, anyone want to do this one on the board? Show us the work, how we get our answer for what arc RC equals to the nearest hundredth. Jonathan, let me give you whiteboard privilege. Thank you for volunteering. And so we need to figure out the central angle here, and we can figure that out because all of these arcs are equal to each other, and this is a semicircle. We can figure out what each of these angles are, so we can figure out that central angle. All right, John, take it away. Yes, absolutely, John. Okay, now you have mic privilege.
Can everybody hear me? Yay. Okay, so what I was going to, so what I did is I figured out, that what we had for the radius, that all of the radius are 7. What I did to figure out what the angles were, I did half the so R to M. I took R to M, and I know the arc R to M is 180 because it's a semicircle. So I took that and I divided that by 3 because I had three other arcs, and that got me 60. So I had so the measure of the angle. So the measure of the angle was 60. So I did. So I did. So then I would have the length equals 60 divided by 360 equals 2 times 7 pi. And so then I would, and I know 360, I know 60, and it goes into 360. So then that turns it into 1/6, and then the 14 2 times 7 is 14, and times pi would get it to oh, not yet. Hold on a second. So when I have I have 1/6 over, so I have 1/6, and then I have 14 pi. So I take the 14 divided by 6 to get 2.33 pi, and then I do 2.33 times 1.34 or 3.14 to get 7.33.
Great job, John. That was awesome. Yep. So 7.33 is the arc length of arc RC. That was perfect explanation. That was really great. Thank you so much for doing that. And hopefully now the rest of you guys understand arc length a little bit better. John had a really great explanation on all the work he did. Okay, so first he had to find that central angle. He knew this was a semicircle, and all of these angles are congruent to each other because the arcs are. So all of these angles are 60 degrees. So that's how he found the M value, which is the central angle. And then he just substituted that into the formula, and he substituted 7 in for radius. And he simplified the formula a little bit and got 7.33 centimeters. Awesome. Thank you, John. All right, one more, and then we're going to go into trigonometry. Okay, so which of the following angles is formed by a tangent and a secant in circle I? Okay, so before we talked about what a secant is a line that intersects a circle twice, and a tangent is a line that intersects a circle once. So which angle is formed? I'm going to put all the angles up here that they're asking about. Angle AIC is this angle right here. Then they're asking angle BIC. Angle BIC is just this angle right here. Angle IEF is this angle right here. And angle GAD is this angle right here. So which one is formed by a tangent and a secant in circle I? So choose A, B, C, or D. I'll wait a little bit for all you guys to choose an answer. So I just highlighted a secant in the circle, so that should help us a little bit. I see 6 of you guys chose an answer, and you are correct with that answer, but there's still a bunch of you guys who have not chosen an answer. Okay, I'm going to highlight a tangent for you now, and then this should make it pretty clear as to which angle is formed by a tangent and a secant. Okay, so the tangent is in yellow. It intersects the circle only once. The secant is in purple. It intersects the circle twice. Which angle is formed by a tangent and a secant? I should have 100% participation on this. So we've got 11 answers. So there's still 8 of you. Looking for an answer from 8 of you guys. Okay, so let's see. Betsy, David. David's away though. Evangelina is away. Kayla, Mary. Mary's away. Mary's back. So waiting for an answer. So we got 15 of you guys. All right, the 15 of you guys who put C as your answer, you are correct. Angle IEF, right? That's this angle right here. That is created from a tangent and a secant. Okay, so again, a tangent intersects the circle once. A secant is a line that intersects the circle twice. All right, let me know if you have any questions on any of these. And again, you can also watch the recording from last week. Mrs. Williams reviewed for Unit 4. Okay, oh my gosh, I can't say the word. Trigonometric ratios. Sine, cosine, and tangent. Those are the trig ratios we're going to talk about today. Hopefully we can get through 501 to 504, or at least 503. If you downloaded that document, you'll see it looks something like this, except the angles. This is just a little clip of it. This is going to show you, if you don't have a calculator, let's say you need to figure out the sine of a 1-degree angle. This is the answer. The sine of a 10-degree angle, and you don't have a calculator to plug this into, then this is the answer. Okay, so just in case you don't have a calculator, you can use that. Or also, go to that link that I put in the chat box before. I'm going to put it in again. Here's an online calculator that you can do trig ratios with. Okay, so we're going to do trig ratios for right triangles only, okay? When we don't have right triangles, then this is called something, the law of sine or the law of cosine, which we'll get to later in this unit. But for now, we're just working with the right triangles. So we have 2 legs and a hypotenuse, okay? And our right angle is directly opposite the hypotenuse. Okay. So here are the 3 trig ratios that you guys need to know. Sine, cosine, and tangent. Okay, and I'm sure you guys have probably heard of these before. Did these in pre-algebra a little bit. Algebra 1. Okay, so hopefully you have some, recollection of trig ratios, but we're going to go over all this again. Okay, so sine of an angle is the ratio of the length of the leg opposite the angle that you're looking at. So let's say we're talking about the sine of angle A. Here's angle A. So we're looking at the ratio of the opposite side over the hypotenuse. Okay, so if here's angle A, Big A is the angle, little a is the side opposite that angle. Here is angle B, uppercase, and side B is directly opposite. Angle C and side C is directly opposite that. Okay? So if we're looking at angle A, we're looking at the ratio of sides of the opposite over the hypotenuse. So little a over little c. That's the opposite side over the hypotenuse. Okay? Cosine is the ratio of the length of the leg adjacent to the angle to the length of the hypotenuse. So the ratio is adjacent over hypotenuse for cosine. So if we're still looking at angle A, the adjacent side is side B, and the hypotenuse is side C. Okay? So here's angle A, side B is adjacent to angle A, and side C is the hypotenuse. The hypotenuse never changes. It's always that side directly opposite the right angle, but your adjacent and your opposite sides will change depending on what angle you're looking at. So if you're looking at angle B and you want to do cosine, the adjacent side is actually side A, and the hypotenuse is still C. So it depends on what angle you're looking at to figure out what the adjacent side is and what the opposite side is. Okay, so that's the cosine trig ratio. And then the last one is the tangent of an angle. And the tangent of an angle is the ratio of the length of the leg opposite that angle to the length of the leg adjacent to that angle. So opposite over adjacent. So if we're looking at side A, angle A, side A is the opposite, and the adjacent is side B. So the ratio would be A over B. Okay? So we remember it as SOHCAHTOA. Okay, SOHCAHTOA. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Okay, so SOHCAHTOA. Now, if you think back to when you did order of operations and you remember it by please excuse my dear Aunt Sally, or when you're trying to remember all the planets, my very excellent mother just served us nachos, and that shows us all the planets. So I'm going to see if you guys can come up with one for the trig ratios for SOHCAHTOA. Can you come up with, what do they call, I'm blanking on the vocabulary word of what this is actually called. When we come up with a little saying for acronym. Yes, that is it. Thank you, Mrs. Williams. Yes, I think that is it. So any volunteer? Anyone think of something? I'm going to give you whiteboard privilege, all of you guys, and if you can come up with something for SOHCAHTOA, maybe to help us remember it a little bit better. So you can raise your hand if you come up with something that you want to write on the whiteboard, or you have whiteboard privilege if you just want to write something up there. Let's keep it clean, though. Yeah, Laurel, that one's a really good one. I like that one. Tying in math, algebra into it. Some of her children are having trouble over algebra. I like that one. I just went to a website and I found a ton of them. That's where I got that some old horse one. Let's see what else I see here. It says, silly old hens can't afford houses till old age. Some old horses can always hear their owner approach. Saddle our horses, canter away happily to other adventures. I don't know if I remember any of these. I think I would definitely remember the one about the algebra student, though. Some old hippie, no, that's not a good one. I'm not reading that one. What else? Some outhouses can actually have totally odorless aromas. I think Laurel is the winner here, though. I like that one a lot. I'm going to put that one on the board here. So, some of her children are having trouble over algebra. I like that one. All right, cool. Okay, so example using your calculator to find the trig ratios. So let's say you want to find the sine of angle that's 52 degrees. Okay, so you want to find the sine of an angle that's 52 degrees. What you're going to do in a calculator, you're just going to press sine, the sine button, and then put 52 in, and it's going to give you a decimal, and we can approximate it to 0.79. Okay, we want to round to the nearest hundredth. But one thing is, you want to make sure your calculator, if you have one of those big graphing calculators, you want to make sure your calculator is in the degree mode and not the radian mode. So you want to go to the mode button and make sure it's in degree and not radian. So that you get the correct answer. Okay, now if you don't have a calculator, you can go again to this link. Oh, I did not mean to put that in there. That was all of the acronyms that I found on SOHCAHTOA from that website. What I wanted to put in there was this website here. That is what I wanted to put in there. Okay. So go to that website, and that you can also put in sine 52, or look at the chart that I gave you at the beginning of the session that you downloaded, and look for, go under the sine column and go to 52, and then you'll see the 0.788, probably approximated to 0.79. Okay, and let's say you want cosine 19. Again, you're just going to press the cosine button, so the cos, and then put in 19. Make sure your calculator is in degree mode and not radian mode. And we can approximate this decimal to 0.95. Yeah, so if you have a calculator, try it right now to make sure you're getting the correct answer. This way you'll know if it's in degree or in radian if you're getting the wrong answer. Okay, so the first one was sine of 52. And the second one was cosine 19. Okay. All right, so what we're going to do, we're going to do some trig ratios here, looking at right triangles. And the first one we're looking at is sine. So we want to write out SOHCAHTOA so it helps us remember the ratio that we're using. So they're asking for sine, so I know it's going to be so, right? It's going to be the opposite over the hypotenuse. Okay, so we're working with this trig ratio right here, the opposite over the hypotenuse. You want to label the sides, hypotenuse, opposite, and adjacent. So if we're looking at angle J, okay, here is the hypotenuse, because that's always directly opposite the right angle. Here is the adjacent side, and here is the opposite side for angle J. If I was looking at angle K, the opposite and the adjacent sides would be reversed. The hypotenuse is always the same, okay? But since I'm looking at angle J, the side that is 11 is my adjacent side, and the side directly opposite the angle is the opposite side, okay? So the trig ratio for sine of J is going to be opposite over hypotenuse, so 60 over 11. Okay, so that is the decimal, and now we want to write it as I mean that's the fraction, you want to write it as a decimal. So 60 divided by 11 we get 5.4545 repeating. So I'm just going to round that to 5.45. Okay, so that is the trig ratio. And here it says, if you are asked the trig ratio, stop here. We don't have to go any further. They're just asking for the trig ratio. If they're asking us to find the actual angle, if they're asking what is angle J, then we'd have to keep going. But for now, all they're asking for is the trig ratio. They want to know the opposite over the hypotenuse and what that ratio is. Okay, so that ratio is 60/11, and that comes out to be 5.45, that ratio. Let's say now this question was saying, we want to know what angle J is. Okay, well then we're going to keep going here. If they're asking to find the angle, keep going. Whenever you're looking for an angle, whenever the angle is missing, you're going to use what's called the inverse trig ratio. So if we're looking for now what is angle J, we have got to do the inverse trig ratio. And the inverse trig ratio on your calculator or even on the table that I gave you, it looks like it's that trig name to the -1 value. So sine to -1, that means the inverse. So again, you cannot get these answers if you don't have a calculator or if you don't have that chart to look at. Okay. So you then would take the inverse sine function. That's the button you would press, and you would put in the 60/11 or the 5.45. And that's going to actually give you the degree measurement of the angle. Now, since this question wasn't asking you for the actual angle, I don't know if these sides on this triangle are actually going to give us something that makes sense. But let's see here. Yeah, you actually get something that kind of doesn't really look like it makes sense. 0.0949, what Nathan got in that chat box. So for this case, just because these side lengths aren't really correct, we get J equals 0.09, we'll round it to 5. Okay? But for this question, it really was just asking you what is the trig ratio. And the trig ratio is just opposite over hypotenuse. So it was 60/11. Okay, let's look at this one. What is the value of the tangent of A? Okay, so again, they want the trig ratio. So we're going to write out SOHCAHTOA. Okay, you guys can choose A, B, C, or D. I'm thinking it probably was 60/61. Oh, wait, what did I put? I put opposite over adjacent. I did the tangent. That's why. Oh, thank you, Mrs. Williams. I did 60/11 when it should have been 60/61. That's why it doesn't make sense. Thank you. So I did the tangent ratio, right, when I should have done the sine. So sine is opposite over hypotenuse. I did opposite over adjacent before, which is why it wasn't making sense. Okay, here is angle J. Here's the opposite side. Yeah, exactly. I was just checking to see if you were awake. Nope. All of us teachers, we make mistakes too, see? It's a good way to learn from our mistakes. So opposite over hypotenuse. 60/61. So that's going to totally change our answer. 60/61 is our ratio. Let's get the correct decimal here so I don't leave you with an incorrect answer. Okay, so 60/61 is really 0.98 if we round it to the hundredth. So 0.98. And then we're going to take the inverse sine function of that. So that's 0.98. Right, exactly, Madison. Now you know how to solve it for tangent and for sine. Perfect. So now let's see what it actually would be if it was the inverse sine. If we want to know what angle J is, then you do the inverse sine function of 60 over 61. And then we get yep, so if you have a calculator, try it. So we get approximately 79.6. Is that what some of you guys got when you did that? So approximately, we'll say. So let me know if that's what you guys got. All right, good. And if you have any questions, just let me know. Sorry that I confused you guys there before. So first I did tangent, really should have done sine. Okay, let's look back at this one. Now this one is actually a tangent one. So tangent, we're doing opposite over adjacent, right? And we're looking at A. So here's the angle we're looking at. I'm going to put a mark there. Tangent is opposite over adjacent. So let's write what the opposite and what the adjacent and the hypotenuse is. The 10 centimeters is the hypotenuse, no matter what angle you're looking at. It's the side directly opposite the right angle, so that's the hypotenuse. The opposite side from angle A is the 6 centimeters. It's side CB, that's opposite. And here is the adjacent side CA. Okay, so if we're looking at the angle, directly opposite. That's the opposite side. Next to it is the adjacent side. It's actually, the adjacent side is actually one of the other sides of that angle with the hypotenuse. Okay. So choose A, B, C, or D. I'm going to wait for a little bit more answers. So far we have 4 answers. So we're looking for the tangent of A is going to equal the opposite over the adjacent. Okay. So with tangent, we're not looking at the hypotenuse at all. Tangent is just the opposite over the adjacent side. Wait for a few more answers. 7 of you guys who chose D, you are correct. So it is 6 over 8, right? Opposite over adjacent. So here's angle A. So the opposite is 6 over the adjacent, which is 8. Okay? So D is the answer there. All right, what is the length of line segment QR? Okay, so we're looking for QR. I'm going to put an X there. We have angle S, and we have side RS. So this is the type of question where you've got to figure out what trig ratio should you use, and you want to look at the information that's given to you. So here's angle S. So let's mark the opposite, adjacent, and hypotenuse, so you have a better idea of what ratio to use. Okay, here's the hypotenuse. For angle S, this would be the opposite side. So that side that's missing that we're looking for is the opposite side. And side RS is actually the adjacent side. Okay, so we have angle S. We're looking for the opposite side, and we have the adjacent side. So what trig ratio should we use? We have the adjacent side, and we're looking for the opposite side. So should we use sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, or tangent, which is opposite over adjacent? So again, we have the adjacent side. We're looking for the opposite side. So really, we shouldn't be worrying about hypotenuse at all, right? Because we have the adjacent side, we're looking for the opposite side. Good, so Helena wrote TOA in the chat box, and that is exactly what we should use. We should use the tangent. Right, so Mrs. Williams wrote the key thing is to make sure you're only missing one of the three things that you need. Okay, if we were to use, let's say, sine, opposite over hypotenuse, we're missing both of those sides. So that's not going to help us figure out what the opposite is. So we need to have one of the sides. So since we have the adjacent side, we want to make sure we use that in our ratio. So you might say, well, cosine has adjacent also, but then we're missing the hypotenuse. So we'd actually be solving it for the hypotenuse when we really want to solve it for the opposite side. So tangent would be the easiest one to use. We only are missing the opposite side, and that's what we have to find. So we've set up that ratio. The tangent of 80 degrees equals x, which is the opposite side, over the adjacent side, which is 2. So the tangent of 80 degrees equals x over 2. Okay, and then you can set this up into a proportion and solve it. So first you want to use your calculator or the chart that was given to you and figure out what's the tangent of 80 degrees. Okay, so figure out the tangent of 80 degrees. Good. Laurel put 5.6712818, so on. So we'll round it to the 100th place value, so 5.67. Okay, so we have 5.67 equals x over 2. Okay. Now we can cross multiply, and we would get 1x equals 2 times 5.67. Okay, so it looks like so far we have 3 answers. So when we multiply this out, we get 11.34 centimeters. So C was the answer here. It looks like 5 of you guys have C as your answer. But please let me know if there's any questions. So notice for this one, we didn't have to do any inverse function because we're not looking for the angle, we're looking for a missing side. So key thing to remember is if you're looking for a missing side, you're going to use the regular trig function, whether it's sine, cosine, or tangent. If you're looking for a missing angle, then your last step is you're going to have to take that inverse trig function, whether it's inverse of the tangent, the sine, or the cosine. Okay, let's see if we can get a volunteer to do the next one. So find the length of BC. So we're looking for BC, so I'm going to put the x here. Round to the nearest hundredth. Okay, so we have angle B, so we want to work with angle B. We have the opposite side. We are missing the adjacent side, and we don't have the hypotenuse either. But we're looking for the adjacent side, and we have the opposite side. And we have angle B. So should we use tangent, cosine, or sine? And then who can set up the problem for us? So raise your hand if you believe you can do this one on the board. Any takers? I will tell you that you should be using the tangent function. We have angle B. We have the opposite, we're looking for the adjacent. Opposite over adjacent is tangent. Okay, I'm going to do this one then so that we can keep going because we still have a lot to go over. So tangent of 15 degrees equals the opposite over the adjacent. So 10.2 over x. Okay, and then we find the tangent of 15. and the tangent of 15 is approximately 2.27. So we have 0.27 equals 10.2 over x. So this becomes 0.27x equals 10.2. Divide out your 0.27. And I get 37.8 approximately feet. So let me know if you got that answer and if you have any questions. Okay, good, Laurel. Anybody else? Good, Madison? Let me, if there's anyone who's confused, good, Cassidy. Okay, here's just a caution. If you round too early, you're going to get an answer that, let's say it's a multiple choice, your answer might come out to be a few degrees or points of a degree less if you rounded too early. So the best thing to do would be do not round until the final step of your answer. So use the value of the trig ratio that was given in the calculator. Otherwise, I mean, I'm sure you'll come up with something close enough that you could probably figure it out, that that's what the correct answer is. But still, if you want to know the exact, closer to the exact answer, then you want to wait until the end to round. Okay, and when we're finding missing angles, we round to the hundredths. But if for some reason the question is asking you to round differently, then you just follow the directions in the question. Okay. Find the length of QR round to the nearest hundredth. Okay, we're looking for QR. Find the length of FD, and this one we're looking for FD. We have angle P. This is the opposite side. This is the adjacent side. No, I'm sorry, this is the hypotenuse. It's my bad. It's the side directly opposite the right angle, so that is the hypotenuse. So we have the opposite side. We're looking for the opposite side, and we have the hypotenuse in that one. So think of SOHCAHTOA. We have the hypotenuse. We're looking for the opposite side. And then this bottom one, we have angle F. We have the adjacent side. And we're looking for the hypotenuse. Okay, so what trig ratio should we use for number 1? And what trig ratio should we use for number 2? Think about which trig ratio deals with opposite and hypotenuse, which trig ratio deals with adjacent and hypotenuse. Good, so Madison says for number 1 we use the sine, and she is correct. We're going to do the sine of 63 equals the opposite over the hypotenuse. And for number 2, anybody know for number 2 what should we use? Yep, we should use cosine, adjacent over hypotenuse. Okay, so the cosine of 39 equals the adjacent, which is 20 meters, over the hypotenuse, which is x. Okay, any volunteers to finish these on the board? Madison, let me give you whiteboard privilege. And you can go ahead. And Katie, if you want to do the second one. All right. Go ahead, ladies. Thank you. Katie, no, we haven't spoken about the special right triangles yet. Yep. So you should get one for the tangent of 45. But in one of your upcoming lessons, you're going to be talking about those special triangles, 30, 60, 90, and 45, 45, 90 triangles, and then we'll talk about those trig ratios. Okay, so number 1, Madison did. That looks great. So sine of 63, we have 0.89. That equals x over 12.9. We cross multiply and we get 0.89 times 12.9 is 11.48. Okay, let's check the second one. So cosine of 39. Let's see. I got something different here. Okay, so the cosine of 39, I get the 0.77714596147. Okay, let's see, and then we're not actually going to multiply that by 20. What we're going to do is then, so if we have the cosine of 39 over 1 equals 20 over x, what you're actually doing is you're going to have cosine of 39 times x equals 20. So you're going to actually have to divide out the cosine of 39. So you're going to do 20 divided by the cosine of 39. So you would do, in your case, 20 divided by the 0.78. If we don't want to round the cosine yet, then we're just going to do in the calculator so that we don't have to approximate too much. We would just do 20 divided by, and then you would put in cosine of 39. And we would get approximately 25.74. So does that make sense, Katie? So that would be approximately 25.74. Yep, so Mrs. Lerner said keep 4 decimals until you're done. This way it'll be much closer. Good, right, so that's what Katie put there. So we're going to be dividing that way. Okay. Good job, ladies. Thank you for doing these on the board. Okay, we've got 1 more minute, so let me just give you